This is lesson 8.1, quadratic functions in factored form. We're going to take a look at quadratics again in this unit, but we're going to go into much greater depth and look at many different parts and aspects of quadratic functions. First and foremost, with this lesson, is to review again what a quadratic function is. A quadratic function is a polynomial of degree 2, and that means that you would have a x squared term to make it a degree 2, or you can have a couple terms, and that would be like this, or you could have a couple terms where you have two polynomials multiplied together where the end result would give you a degree of 2 as well. So if we FOILed this, we would get a degree 2 function. We're going to review also what x-intercepts and y-intercepts are. We've talked about this in the past. Again, if you plug a 0 in for y, the x value you get out would be the x-intercept. In other words, where it crosses the x-axis or horizontal axis. The y-intercept is found by plugging a 0 in for x. You plug a 0 in for x and you will get the location where your graph crosses the y-axis, and therefore called the y-intercept. Another term for y-axis is vertical axis. Now what's new is this piece right here, the zero product property. Very important, very powerful, and that's what we're going to be keying on in many of these lessons. What this tells you is that if you multiply two things together like this and you get 0 for an answer, then either A was 0 or B was 0, because we know that anything times 0 is indeed 0. So that's what the zero product property says. If you have two things multiplied together and 0 is the answer, then you know one of these is true. So what does that mean to us? Well, let's take a look at an example, and we're going to look at this one first. This is not in your guided notes, so you're going to want to write this one down. This says 2x minus 3 times x minus 3 equals 0. In other words, two things multiplied together give you 0 for an answer. So therefore, one of these two things must have been 0. So here's what we do. The question can be as easy as this. What can I plug in for x so that when I subtract 3 from it, we get 0? So in other words, how can I make this become a 0? And this one's pretty straightforward. The answer would be a positive 3. In other words, if I asked, how can I make x minus 3 equal 0, I would just solve for x. So this is considered one solution, because if I plug 3 in, 3 minus 3 is 0. No matter what this left one is, that times 0 is going to give me 0. Now, when it's not as obvious, like this one, how can I make that one 0? Well, it's a little bit more interesting question, but the nice thing is I can still solve it the same way. And that is, how can I make a 2x minus 3 equals 0? And I just solve it. I add 3, and I divide by 2, and x is equal to 1.5 or 3 halves. And these are considered the two solutions. These are considered solutions. These are considered roots. These are considered x-intercepts because we plugged a y in for 0, or 0 in for y, which you don't notice, but we'll get to that later. Alright, so let's try some more complicated ones. How can we get a trinomial to look like this? And this is what the last chapter was all about. How can we factor it? Well, if I can factor this, I am indeed creating two things being multiplied together, and I'm getting 0 for an answer. So I put in x and x, factors of 35 that give us a sum of 2. It's a negative 35 there, so 35 times 1 of these is negative. 7 times 5, well, there's two things that have a difference of 2, and if I make this a negative 5, I get negative 35 when I multiply, and they have a sum of positive 2. So I'm going to say positive 7 minus 5. Now what are the solutions? Well, if I plug in a negative 7, this one becomes 0. If I plug in a positive 5, this one becomes 0. So my two solutions are negative 7 and 5. Next one, again a little blast from the past here, multiply those together. We have 18, that's the product. The sum is negative 9. So what are the factors of that? Well, 6 times 3, if I make them both negative, I get positive 18 as a product and I get a negative 9 as a sum. So I would have 2x squared minus 6x minus 3x plus 9 equals 0. And then I will factor by grouping. I'll take a 2 and an x out, and I'll be left with x minus 3. On this one I'll take a negative 3 out, and I'll be left with an x minus 3. And then now I'm going to factor out an x minus 3, and I'm left with 2x minus 3. There's the first part, there's the second. Now the difference in what we did in the last unit compared to now is now I have an equal 0, which means I can go one step further and I can solve it. If I plug in a positive 3 here, that will make that 0. This one's not quite so straightforward, but it's very similar to this one. 2x minus 3, what did we need to plug in? Positive 3 halves. So those are the two solutions. So we're really going one step further. We can set it equal to 0 and solve now after we factor. So let's take a look at a graph and answer these questions. What are the x-intercepts and the y-intercepts? Now these are nice because all we're doing is looking at the graph and asking ourselves, where does this graph cross the x-axis? Right there. That is an x-intercept. And down here at negative 4, that is the y-intercept. Next one, we have two x-intercepts. We have, that looks like negative 3, and we have negative 7. So two different x-intercepts. Up here is our y-intercept. Looks like positive 7. And that's being able to tell from the graph, which is pretty nice. Now without graphing, how do you get those answers? Okay, well, as we said earlier on, if we say x is equal to 0, we will get the y-intercepts. Okay, so what do? X equals 0, so I have f of 0, I'm plugging in 0, and I get negative 0, parentheses 0 minus 3. 0 minus 3 is a negative 3 times 0 and we get 0. So the y-intercept is 0. Alright. If I say y is equal to 0, I'm going to get the x-intercept. Okay, so how do you make y equals 0? Well, the y is actually going to be where the f of x is. And I'm going to actually write this way. Instead of equals f of x, well, actually, you know what? Let's write that out. Okay, so when I say I want to have y equals x, I'm actually making the f of x become 0. So y equals 0, f of x equals 0, they mean the same thing. So we replace this piece right here with 0, and now we're back to the question that we had before. How can I make these two things that are being multiplied equal 0? I would say that if I plugged in a positive 3 right here, I could make that 0, which means 0 times anything is 0. And right here, it's just x. Well, I can just plug in a 0 and make that a 0 just by that. It's not a very hard modification there at all. So I have two solutions. In this case, I have 0 and 3. I have two x-intercepts, 0 and 3. Next one. Alright, how do we do that? Just like before, the first one we did was x equals 0. If I take plug a 0 in for x, I want to get the y-intercept. So I have y equals, and I plug a 0 in. And I get y equals 5. Because 0 squared is 0, negative 6 times 0 is 0, and this is our y-intercept. If I say y is equal to 0, I'm going to find the x-intercepts. So I'm going to write this again in a different order. Instead of saying equal y, I'm going to say equal 0. So I need to change this trinomial into two binomials being multiplied so that I can use the zero product rule. So factoring, and a lot of us were very good at this last unit. Factors of 5 times 1, you want a negative 6, so both of them are negative because negative 5 times negative 1 is positive 5. And I'm going to say negative 5, negative 1. So my solutions here are positive 5 and positive 1. These are the x-intercepts. Alright, and this ends lesson 8.1.